Hey, hi there. Welcome to the statistics module. So in this module, we'll be covering a series of videos and lectures where we'll be discussing about statistics from scratch. What does it mean? Right there to its applications. How do we implement statistics in Python? So before we move on to understanding or introducing you to statistics, the first question which pops up is, what is statistics? So statistics can be called as a field of study which concerns itself with the collection, organization, analysis, interpretations, and presentation of data. Okay. So when you talk about presentation, you're talking about dashboards or, drawing insights from data, doing visualizations, all those things require statistical knowledge. But before we move on to the technical aspects of statistics, I first want to, lay down the gaps between academics and industry. Now, if you look at the steps, right, the different stages of statistics, collection, organizing, analyzing, interpretation, and presentation of data, right? So with respect to that, I have drawn a table here at the school, college, and a corporate level. So when you talk about all these steps, if you look at the school and college level, most of the questions or concepts which we try to apply is always through direct question and answers, theoretical questions and answers. We never really, deep dive into the practical application of statistics. And because since we do not do that, we use the same age-old technique of manually solving questions, right? We even create graphs on graph papers without using any tool. But when it comes to the corporate, collection typically happens in a data warehouse or a server, data pre-processing tools, insights drawn through, exploratory data analysis, dashboard, interacting with client and all these require extensive programming knowledge as well as the theoretical concepts of statistics. Right now, one may know the theoretical concepts, but they don't know how to apply. And when you know once how to apply the statistical knowledge, you will then try to understand and realize like where are the loopholes present inside statistics, what kind of problem statements I probably will not be able to solve using statistics, what kind of problem statements I will be able to solve using statistics. Where does statistics come in the domain of machine learning and data science? How do I connect my knowledge in statistics to applying it in machine learning modeling? That is what we are trying to do. And that is what I'll try to do in the next series of videos. So main gaps which are there lies in these 4 or 5 points where we talk about where we typically answer theoretical question answers in colleges and schools, whereas in corporate we have to use programming languages or some kind of automated structure of drawing insights. What kind of other pre-processing techniques which we use, which we generally do not find in statistics, which is required for exploratory data analysis, right? So worry not, since we are here, that is the purpose of Edividend, that is the purpose of my company, which is Edividend, and we will try to close that gap as much as possible, right? But before we dive into statistics, the first question we should ask ourselves is, what is data and what are its types, right? If you remember in the Python first video, right, we also talked about what are types of data which Python understands. Similarly, before we go to statistics and try to go into more technical details, we first need to understand what kind of data is available in the market today. Right? If we talk about numerical data, we all know what is numerical data. We have textual data, we have images, which also can be dealt with data with the onset of new technologies and comprehensive modeling techniques. Data can be fed in, in the form of an image, audio, or a video as well, right? So but typically, when we talk about statistical interpretations or using statistical tools or modeling techniques, typically can deal with numerical and textual data. We talk about numerical and textual data in the purview of statistics, whereas image, audio, and video are certain type of data which requires more advanced, pre-processing techniques. Ultimately, my machine has to understand numbers. Machine will take in numbers, but how do you convert this image to a number? How do you convert this video to a meaningful number? Is something which you are going to understand in artificial neural networks or deep learning concepts. We'll be studying convolution neural networks for image kind of data. We'll be studying recurrent neural networks to understand sequential data, which is audio, And for video, we'll use a combination of both. But for now, we'll go step by step. The first two type of data which you typically have to deal with, which is mostly available in today's market, is numerical and textual, and that is what we are going to try to understand using our statistical techniques. Okay, so let me just draw you a brief outline of what are different types of data under the umbrella of statistics. So if you look at this, so the first two basic divisions of data, types of data, is quantitative and qualitative. These are the broad divisions of data. Okay, broad types of data: quantitative and qualitative. Quantitative, we all know, which can be defined by a number. Qualitative is something which cannot be defined by a number. Okay, now, why is it so important for us to understand what is quantity and what is qualitative? Is because later on, when we will move to the exploratory data analysis part, there, what kind of technique you use to pre-process data depends on the type of data which you are handling. As you saw in the visualization module also, what kind of graphs you're going to use depends on what kind of data you are handling. So that is the power of data science. Sometimes you may not require a domain knowledge. Of course, if you have domain knowledge, it adds value to your model, of course. But if you do not have, you still can perform modeling, right? All you need to understand is how do you deal with this data. And it's not just about being a data scientist, but people from any background, while analyzing digital data, has to know how to interpret data and what are different types. So quantitative typically can be segregated in two parts: continuous and discrete. I'll help you explain all these points using suitable examples, but for now, let us have a look at the chart. Qualitative, on the other hand, can be termed as ordinal and nominal. If you want not remember the names as of now, it's fine. We'll take some examples and then we'll move forward with it. Now, if you look at continuous, we can see different types of examples which you see here. Now, let us look at the examples in much more detail. Now, in quantitative data, the broad the segregation or the broad type of data was quantitative. And let us have a look at the examples of quantitative data: height and weight, square footage area, or speed of vehicles. If you look at all these examples, they tend to have float or decimal points, right? Or you can think of a fact that they are continuous in nature. A number of sales may not have a float. It's not a float, but they will be continuous in nature. Whereas if you look at the other part of quantitative, number of dependents, credit score, ratings, which you give in a movie, say rating out of 10, rating out of 5, number of days, they tend to be integers. So if you look at this, these are whole numbers typically, and these are rational numbers of fractions. Yes, sales 1302 is an integer, but if you think about it, it will tend to be continuous. Just to give an example, if I ask you, what are the natural numbers between 1 and 10? You'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But if I ask you, what are the possible set of numbers? What are the all possible set of numbers between 1 and 10, including decimal points? What will you say? 1.111 can be anything, 1.001. So that makes it continuous. If there are too many unique values in my data set, that data becomes continuous, tends to be continuous in nature. And all these things we'll try to understand in the upcoming videos as well, because we'll be dealing with probability distributions. So identifying data as discrete and continuous is the first step towards understanding probability distributions in statistics. Okay, so that is why this section is called as continuous, whereas this section is called as discrete or discontinuous. Based on this two, we in fact have continuous and discrete probability distribution in statistics. That is how important it is. However, if you look at the second broad category, which was qualitative, ranked first, second, third, fourth, grades, A, B, low, medium, high, one quality, good, bad, or whatever it is, medium, right? On the other hand, we have gender, which is, say, male, female, Asian, Homo sapiens, and brown. Eye color is brown. Now, if you look at both these sections, both of them are objects or string type data, right? Qualitative is string type data, textual data. It can be alphanumeric, can be anything, but it's ultimately strings. However, if you look at quote these two sections carefully, you'll notice that on the left-hand side, the section seems to have some kind of order. May not be a numerical order, but some kind of hierarchy. First, second, third. A plus grade, A, B, C grade. Low, medium, high. Good and bad. There seems to be there seems to be an order in this data. That is why it is called as ordinal data. On the right hand side, you will see there is no order. Ethnic, male and female. Who is superior? No one. Right? Everyone is equal. Ethnicity, everyone is equal. Homo sapien species, everyone is equal. Eye color, brown, whatever is black, blue, whatever it is, they did not have any order. That is why they are called as nominal. So whatever data set has an order to it and a string in nature is called as ordinal, and the vice versa is called as nominal. Right? Based on these segregations, right, we use different pre-processing techniques for all these different types of data. Right? Based on the fact that my data is ordinal, I'll probably do level encoding in pre-processing. Where if it is nominal, we'll do one-hot encoding. I'll just give an example, because all these are string type data, and before doing modeling or before doing any kind of other predictive modeling, we have to convert it to a number. And the way we do it is by first understanding what kind of type of data does this particular column belong to. If you look at this carefully, this section, this half, right, is called as categorical data. So discrete, ordinal, and nominal are called as categorical data. And if you revisit my visualization codes, they will see somewhere there must have been a column which is discrete, yet I used a counter to understand the number of count of each of those categories. Because discrete numbers, ratings 1, 2, 3, 4, tend to categorize my data. Suppose I gave a rating, suppose there's a movie which has received rating 4. So the 4 number basically represents all those users, all those movies which have got a rating 4, right? And qualitative is always categorical in nature. So broadly, if you think about it, more than quantitative and qualitative, I can basically segregate in-time data which I find in any programming language into 2 types. One is categorical, another one is continuous. Because for continuous, you'll be using different kind of plots. For categorical, you'll be using a separate kind of plots. So yeah, so in this video, we have talked about statistics, the gaps in the present curriculum. I also assured you that we would try to remove those gaps as far as possible. I assured people coming from any background can learn statistics from scratch, because I will be teaching you from basics, from a layman's perspective, without using too much of a technical nomenclature, right? When we also started discussing about our type of data which we have in the market, what are its sources, and we also discussed that when it comes to statistical analysis, it has its own limitations as well, because it can deal with textual and numerical data more efficiently than the other types of data which we came across. We also understood that data, numerical and textual, can be broadly finely segregated into continuous and categorical. Broadly segregated into quantitative and qualitative, but if you deep dive into it, you'll find that data is either continuous or it is categorical. Even discrete numerical data can be segregated as categorical data. So in the next session, we'll be exploring the world of statistics. We'll slowly start to understand what is probability, what are its distributions available, and slowly some statistical theorems as well. And from the next video onwards, we'll have 2 sections. One is me explaining to you the technical concepts or theoretical concepts using a presentation, just like we did today, and also the application part of it, which we'll try to do in Python. So both your theoretical concept and the application will go hand in hand. So wish you all the best. Keep practicing. See you in the next video.